Faber instantly noticed something strange about these two images. Depending on a star's location in the field of view, the shape of its radiating tendrils changed. To Faber, the most likely cause of these changes was interference from the supports holding the mirrors inside Whiff-Pick, combined with some form of spherical aberration in Hubble's primary or secondary mirrors. By that evening, she was arguing her case with Ed Groff, a longtime member of the Science Working Group and the telescope's data and operations team leader, and Todd Lauer, one of Faber's postdoc students whom the team had hired. Neither were convinced. All of them agreed, however, that if they could get a series of pictures taken by Whiff-Pick at a range of focuses with the star placed at the center of the image, they could very quickly define the cause of the image's fuzziness. According to this plan, the secondary mirror would be moved after each image, changing its distance from the primary, and thus the focus. The problem with this plan was that it wasn't the plan that the Marshall and Hughes-Danbury engineers had worked out for getting Hubble in focus. Olivier and Basedow remained reluctant to do it because it required moving the secondary mirror far more than planned. If the mirror got stuck during any of these focusing maneuvers, the telescope would be left permanently out of focus. For Faber, convincing them to change their approach was made more difficult by her newness to the project. The engineers didn't know who she was. She was further hampered by her lack of knowledge of the field of optics, as well as her limited knowledge of both Whiff-Pick and telescope. Compounding these obstacles were the strong disagreements between the scientists and engineers. The engineers at Hughes-Danbury, for example, were claiming that their software was able to fit the images and had found nothing wrong with the mirror. They refused to release these data, however, which made it impossible for anyone else to check it. Meanwhile, Burroughs was hopeful that the focus issues were caused mostly by coma. If so, they could fix the problem in two ways. First, by tilting Hubble's secondary mirror slightly in just the right way, and second, by using the actuators on the back of the primary mirror to change its shape slightly. Though Faber was skeptical that coma was the problem, she was also eager to pursue any solution. She didn't know much about the actuators, however, and was having difficulty finding out. One time she spotted a Hughes-Danbury engineer in the hallway of the Goddard Operations Building. She thought, here was someone who would know exactly how the actuators work, as well as their limitations. She buttonholed him and began asking questions. Even as he gave her sketchy answers to her questions, the man began walking away from her down the hall. He was really brushing me off. We were walking down the hall and he was being rude in the way some people are deliberately rude. They know you want to stop and talk to them, but they don't stop. They just keep walking, and they make you tag along. So I was tagging along, asking him about how I could learn about actuators, and did he have any reports about them. What do you want to know about them for? He asked as he moved away. Maybe there is something wrong with the primary, she explained. We could use the actuators to fix it. The engineer accelerated his walk. You better not let anybody hear that you're talking about them, he said over his shoulder as he left Faber behind. You'll get into trouble. For the next week, while she, Burroughs, and her graduate student John Holtzman carefully picked apart the two images available to them and argued over the cause of the strange shapes they saw there, they also began a concerted campaign to get the project to take more Whiff-Pick images. They wrote and presented new image proposals each day. Faber began inviting herself to the morning planning meeting, describing the work they were doing and pitching their proposals. On June 8th, Faber had to leave for about a week to do work for the Keck Telescope Science Steering Committee, of which she was then a co-chair. Before going, she wrote a long memo to Jim Westphal, explaining the situation and the political landscape. According to this memo, Jean Olivier was sounding increasingly desperate. She also noted how the Hughes-Danbury chief engineer, Bob Basedow, is a smart guy, but he's fighting the problem with both hands behind his back. Because no one at his company seemed willing to admit there was anything wrong, he was unable to bring an objective mind to the problem. She then explained what she had been trying to do. Get the system to appreciate the need for a simple focus run, she wrote. Look ahead and understand the primary mirror actuators and what they can do. Then she added, I don't have any conclusive model yet myself. However, the situation I'm worrying about most is large amounts of spherical aberration and some defocus. I haven't told this to anyone else, but John Holtzman and Roger Linz, but it keeps me awake at night. By the time she returned on June 17th, Jean Olivier had had enough. After watching the Hughes-Danbury engineers struggle for another week with the optical sensors, he had finally agreed to the idea of doing a focus run using a series of Whiff-Pick pictures, beginning on June 14th. These pictures only made the situation more depressing. The amount of fuzziness they showed suggested an error far greater than anyone expected. Holtzman pointed out something to Faber that shocked her further. One day, as they drove to Goddard to work, he explained how the units of measurement the project had been using to describe the focus problems tended to fool people into thinking that the error was not serious. The numbers were small and made the problem seem smaller. If the error was measured in a different way, it made the grossness of the error much more obvious. At that moment, Faber had a flash of terrible insight. Oh my God, she thought. This is horrible. Then, on Tuesday, June 19th, Bob Basedow finally gave the project a detailed report on how the actuators worked, explaining that they could only change the primary mirror's shape by at most 10%, far too little to correct the now estimated error, regardless of whether it was coma or spherical aberration. Months later, Faber scribbled an extra comment at this point in her daily notebook. This is the moment we find out that we are doomed to failure. Still unable to convince anyone of her belief that spherical aberration was the primary cause of the focus problems, on Thursday, June 21st, she and Holtzman decided to use Burroughs' simulation software to create their own models. Holtzman fired it up, and together they began to try to recreate the star images by using different amounts of spherical aberration. If they could create a simulated image that matched a real one, they would prove that spherical aberration was the cause of the telescope's fuzziness. All through Thursday, Friday, and Saturday, they labored over the computer, slowly calculating and printing out a set of 6 simulated images, each based on a different amount of spherical aberration. Periodically, Faber would drive over to Goddard to pick up additional image data from Hubble itself. They would then lay their simulated printouts on a conference table next to the printouts of the actual images, comparing them. By Saturday morning, they were finally sure. One particular picture from Hubble showed a series of concentric rings surrounding the central star core, which they dubbed the smoke ring image. One of their own simulated images duplicated this image almost precisely. They knew that on Monday there would be the regular weekly project meeting, much more formal than the daily operations meetings, and attended by all the most important players in the project. At that meeting, they would have the chance to make their case. Moreover, they knew that the entire group of project scientists from all 6 science instruments were gathering in Baltimore for the already scheduled quarterly meeting of the Science Working Group, set to begin on Wednesday. It was essential that the project had a clear idea about Hubble's status when that Science Working Group meeting started. They began to prepare their presentation for the Monday project meeting, with Holtzman creating view graphs showing their simulations side by side with the real images, and Bob Light, one of the other postgraduate students working on the WIFPIG team, preparing view graphs showing the actual distribution of light produced by Hubble's image compared to its predicted performance. Faber, meanwhile, kept going back and forth to Goddard to pick up more image data. As she walked into the control room late that Saturday afternoon, she found the engineers standing in a group, staring at a monitor showing the smoke ring image and trying to figure out what could cause such an image. They were completely mystified, she remembered. She quickly sketched out a crude drawing, showing how spherical aberration combined with Hubble's optics could produce the smoke ring. "Wow," said engineer Keith Kalinowski. "You ought to go down and talk to those Hughes people." Basedow and his people had just been there and had been equally perplexed by the smoke ring. Faber decided to take Kalinowski's suggestion, though in one of my rare moments of tact, I sort of eased my way into the room. Bob Basedow and John Mangus, Goddard's optical expert, were there, discussing the situation. I could see that people were very puzzled. Gently, Faber offered to explain the smoke ring image, once again making her crude sketch. Basedow's face went white, Faber remembered. It finally dawned on him what was going on, the magnitude of it. At that moment, Mangus pulled from his pocket his own carefully rendered diagram, identical to Faber's, but very professionally produced, to scale and labeled. He laid it on the table and quickly used it to describe the physics of the situation. As Faber was leaving the room, Mangus joined her. Out of curiosity, she asked him, "John, you knew all about this. Why weren't you telling these people this? You had that sketch right in your pocket." Mangus replied coyly, "I was waiting for you to show up." Though he had solved the problem enough to prepare his diagram in advance, he hadn't wanted to be the first to unveil it to the others. Like those who had been slapped down at Marshall for reporting bad news at quarterly meetings, he as a government employee feared the consequences of being the bearer of bad news.